and day 2. And the focus of day is turning decimals to octals, basic 8. So the premise is the same. We got to remember in terms of our octals, the premise here is that we have 8 to the 0, 8 to the 1, 8 squared, 8 cubed, 8 to the 4th, and so forth in terms of how we're going to write every number. You do not have to stay for the entire class if you don't wish to. I should be done in 10 minutes with my examples, which is the same thing as 1, 8. Oh, these numbers get kind of big here. I wrote them down yesterday, but 8 times 8. I know that's 64. Times 8. 512 times 8. 4096. And of course the numbers can get bigger, but I want to do times 8 one more time. 32768. So these here are the 8 to the nth numbers, and which are the same as these ones right here. And so for the trick here is you want to find a number 8 to the n that is less than or equal to your decimal number, and this will be the start of your hexadecimal. All right. So this one, it requires a little bit harder. It's a little bit because we're not just turning the switches on and off. You are also, you want to find a number that is less than the hexadecimal, and then you will utilize a times 8 to the n minus 1. Or to the n, sorry. Right there. So, best thing here, like I said, it's an example. These are the numbers that you're using. You want to find out the biggest number. You want to find the smallest 8 to the n. The largest. And actually, I realize I have that. Now, you know what? I'm sorry. I'm getting these backwards here. I don't know. I'm trying to rush it, and that's my small. That's what I'm doing. Mistake. You want to find.
Take your time.
We want to find the smallest 8 to the n that is greater than the decimal. That's what I meant to say. So let's have you give me a decimal number. Give me a number.
4.
Well, we're going to start very small. So, okay, we're going to go 4. And we want to change this into its octal form. So, what is the smallest number that is bigger than the decimal? I meant to put -1 right there. Please note that I had to add the -1. What is the smallest one that's bigger? Also the same thing as the largest 8 to the n that is less than the decimal. So which one? Which number? We're talking about these numbers right here. So in the octals, these are the numbers we are working with. So which one is the smallest that is bigger?
I say 8.
8. Okay. So 8 is the smallest one that's bigger. So that means we have to go down one less. So this is where it's in terms of your thinking. We want to. The idea here really is that we want to focus and end up utilizing this one right here for this example because the 1. We want to use the 1 because we don't want to go too big. Okay, you'll see what I mean. So this answer is going to be 1. If we think about it in terms of the boxes like we did last time, all right, it's 1, and we're going to multiply that by what to get 4?
4.
4. And that's basically my answer. So when I'm doing the table, I have 1, 8, or sorry, 1, 8. I don't need the 8. I only need the 4. I only need the 1, so the answer is 4. And that seems kind of obvious. The answer in octal is also 4. What this kind of tells us is that the numbers 0 through 7 are the same in decimal and octal. So 4 is 4. Let's get a number that we actually have to do this type of work though. So now give me a number. Give me a 2-digit number.
17.
17. And we want to change that into octal. So I'm going to make my table. I'm going to list out the numbers backwards. 1. Does that work? Are we going to utilize 1? Is that less than 17?
Yes.
Yes. The next number, 8. Is that less than 17?
Yes.
The next number, 64. Is that less than 17?
No.
No. So we're not going to use those. So what that tells me is that 17 as an octal is a 2-digit number. It is 2 digits, okay? So how many 18s go into 17?
0.
No, how many, sorry, how many 8? I said 18.
Oh,
How many 8?
18.
I did say 18. How many 8s?
2 and 1 left over.
2, and then there's a remainder of 1. So it's 2. And so that's going to give me 16. And now I got to go 1. So now I need to divide this 1. I need to take this 1 and I need to take that 1 and I need to divide it by the next number, which is 1. So how many times does 1 go into 1?
1.
1. So 17 is equivalent to 81 in octal. Or wait a minute. So oops, that's not 81. 21. 21 in octal. Now, how do I know that? Because this is the same thing. What we're saying is it's 2 times 8 plus 1 times 1. That's just to check my work. So 17 in octal is 21 or 21, however you want to say it. Let's try another one. So there's a lot of little bit like long divisions that's going to be going on here. Let's get a bigger number. Let's go bigger.
48.
Let's go bigger.
148.
148. Okay.
He blacked.
What is that?
He blacked.
So let's talk about our table here. 1. Are we going to use that? Of course, that's obvious, right? Next one, 8. Is that less than 148?
Yes.
Yes. The next one, 64. Is that less than 148?
Yeah.
Yes. The next one is 512. Is that less than 148?
No.
So we're not going to use the 512. All right. So now it becomes divisions. All right. So I'm going to show this division a little bit different in the form. So we're going to take this 148 and we're going to divide it by 64. Okay. How many times does 64 go into 148? Sorry, I meant to do, I should be doing it the other way. How many times does 64 go into 148?
Would it be 2 times?
It'd be 2 times. Okay, 2 times 64 gives me 120, 128. We're going to subtract that, right? And that gives me 20. So that means that 2 goes right there. Okay, so now we're going to take this 24, or this 20, and we're going to divide that by 8. How many times does 8 go into 20?
Twice.
Twice. 2 times 8 is 16, which leaves behind a 4. So this becomes another 2 from there. And of course, once you get to the last one, that last digit automatically goes into the last spot because it's 4. How many times does 1 go into 4? The answer is 4. So 148 is equivalent to 224 in octal. The process is very similar to what we did. Okay. So the hardest part, and I'm going to be very lenient. So to read Angel's question about how to put it into the bars and inside the actual assignment. I'm gonna look for you to, I'm gonna be a little bit lenient in terms of the work on this one, in terms of how you show your work, because it's just gonna be, a little bit different. So I don't want to do one. I'm not gonna do one of the exact problems in your homework. I just want to do something bigger so that you can see the process of what you're doing. You're dividing, all right? All you're doing is doing some dividings, and you're taking it step by step and dividing, and you're going down the line. Basically what you're doing is you're trying to find the remainders. How many times does that digit go into, or how many times does that 8 to the nth value go into the decimal number? And then you go to the remainder and you click over to the next side. So 2, and then we had a remainder 20, and it's that 20 we go into the next one. So now let's go one more large number. Let's go larger than 148.
180.
Okay, 180. You want to do this, turn this number into its octal. So 1 seems obvious, we're going to use. 8, obvious that we're going to use. 64, obvious that we're going to use. 512, will we use the 512?
No.
No. So once again, we're going to have 3 digits. Now, if my 3-digit number that you use was bigger than 512, then we would have had gone one more step, one more division. So 180, we're going to divide that by 64. Okay, how many times does 180 go into 64? 2 times. So there goes my 2 right there. Okay, that's 128 that we subtract, and doing that gives me a remainder of what?
57.
Close.
52. 52.
52. All right, so now we're going to take that 52, and we're going to do what to that 52?
Divided by 8.
Divide by 8. Okay. How many times does 8 go into 52?
6 times. 6.
There goes my 6. And 6 times 8 is?
48.
48. which leaves behind 4. And we know, where does that 4 go now?
It goes in the one box.
It goes into 1 because it's just 4 times 1. And there you go. 180 is equivalent to 264 in octal. Okay? That's how we do it. Questions? So, I mean, it's Google. The Google Doc is not really meant, or is really there available for you to show. Now, if you were going to be showing in your homework, basically I want to see that 180 divided by 64 gives you 52. Gives you 2R52. This is kind of like, if you really want to show your work, it gives you 2 with remainder 52. Then you do that 52 divided by, and if you're wondering, oh, I don't have a division symbol, you can do it like this. Divided by 8, that gave us 6, remainder 4. And therefore, these are my numbers. Once you get to that last spot, you automatically know that it's just your numbers. So the answer here would be 264. Like that. That's how you would show your work. So let me do one more example where we're going to show our work this way. If you really want to show your work, because some of you are going to say, I don't know how to do it, I'm having problems, and I'm going to want to look on your Google Sheet. If you understand what's going on and you're doing your work on a separate sheet of paper, you're fine. But if you're struggling and you need my answer, so let's get a number bigger than 512 on my last example. Somebody, any number, and then we'll be done.
You said bigger than what?
Bigger than 512. 685. 685. There you go, from TJ. Let's get this to octal. Okay, so we know we want the 1, the 8, the 64, the 512, and we're not going to go any further than 512. It's kind of obvious. If you want to write down what the next number is, what is it, 4096? You can write that down, but this right here tells me that I'm going to go to 512. 512 is the biggest number for 8, base 8, that is less than 685. Okay, so now you might have to do this work on the side, like the long division on the side, okay, because you need to find like the remainder parts of it. So 685 divided by 512 gives me what? Now, you're not writing a decimal. We want to write in like remainder form. So how many times does 512 go into 685? Once. Okay. And what is the remainder that I get? Now, if you're struggling and you don't know how to do you're like, well, how do I find the remainder? Well, you do 512 times 1 is 512. So it's just 685 minus 512. What do I get?
173.
Okay, now, so there's a 1 right there from this remainder. So now 173, and we're going to divide that by 64. How many times does 64 go into 173? Twice, okay? With the remainder. Now, you're wondering, well, wait a minute, well, how am I going to do that on my calculator? Well, let me show you. Since it was 12, I don't know why I'm clicking on I'm a little dunce. I'm clicking on my my computer when it's on my iPad. So I'm going to take the number that I had. What was the number? Well, it's 173. And I'm going to subtract 64 times 2. because it went in there 2 times. Okay? And there's my remainder. So what's my remainder?
45.
45. Okay. And what am I going to do with that 45?
Divide by 8.
Divide by 8.
You get 5.
I get 5. And 5 times 8, I think we can do the last ones in our head. What's 5 times 8?
40.
So what's my remainder? 45 minus 40.
Oh, 5.
5. And if you were going to do that with the calculator, it's 5 and 8, so it'd be 45 minus 5 times 8 would give me my remainder of 5, or 8 times 5, however you order you want to do it. And so I get another 5 right there. So 685 is equal to 1255 in the octal. And that's it. Okay? So I kept the numbers for the most part rather small. I think at the very end I got to like 4-digit numbers, or numbers that you'll have to go to 512. I don't believe I did any problems in your homework where you're going to have to go up to 4,096. Maybe the last problem, just as like a challenge one like that. But that's it. Convert your numbers from decimal into octal, just like we did. I'll upload these solutions. I'll upload the video as well. And the remaining time of class is asynchronous. That's all I have for you.